You want the tweezers to be like Cuomo. You want them to grab and then lock it down. Grab, lock them down. Y'all excited? What we're going to be doing today, folks, is fixing a MacBook. I know what you may be thinking. You said, what if I don't want to fix a MacBook? Well, I don't give a shit what you think. And if you don't want to fix a MacBook, you can get the F out of here. So we're going to get started over here. We have an A1708 MacBook. We are going to open up Paul Daniels' software. It's called Flex Board View. First thing we have to do is figure out if we can get it to work. It is often a challenge. And we're going to open up a schematic in a board view for an 820-00840. And we're going to get started on a MacBook repair. Wow, it actually opened up the schematic and the board view perfectly with no aggravation. It just worked. First thing we notice when we take a look at this MacBook is that it's fairly dirty. Let me just get my overhead camera working. My overhead camera appears to be protesting the cold. What do you guys see? What do you guys see? Okay, you guys are blind, so I'll put it under microscope for you. Ready? It's okay. I understand. I understand. Listen, eyesight goes bad as people age. You guys have been following me for a long time. I really appreciate that you've been here for as long as you have been. You know, sometimes it is what it is. Let's try this again. What do you guys see? What do you guys see? All right. You see greeny. Very good. Now, what do you think U2890 does? Let's see if you guys can guess, all right? What do you think U2890 does? So we're going to put it on screen over here. U2890. What do you think this thing does? What is this? What do you see? Talk to me, people. Talk to me. Come on, chat. We're going to figure this out together. CPU power. What the where do you see CPU power here? No. No! Next. Thunderbolt, Wi-Fi. Okay, let's try this from scratch. Stop guessing for a moment and tell me why you believe what you believe to be true, okay? So somebody said Wi-Fi. Tell me why you think this is Wi-Fi. Why would you think this is Wi-Fi? USB-C, good guess. Thunderbolt, very good guess. Power for ROM BIOS chip, beautiful. Okay, so when you see this mossy miso shit, it's usually some sort of BIOS chip of some sort. It's a ROM chip usually. That's what this mossy mossy stuff usually means. Now, TBT, that's not like Throwback Tuesday. That's Thunderbolt. TBT, Thunderbolt. A lot of this job is really just kind of guessing what all these little weird-ass acronyms mean. It's one of the reasons that I hate acronyms as much as I do, and I think they're cancer. So if you go over here and we just take a look at this chip, let's just click and try to get an idea of where it's talking, right? So if we were just to, go over here, you could see that this, it's going right down here. What does this go to? Oh, this goes to this chip over here. What's that chip do? Here we go. That is a CD3215. A CD3215 is the USB-C port controller. So that seems to be a ROM chip that speaks to our USB-C port controllers. That is going to be necessary in order for the USB-C port controller to negotiate 20 volts with our charger. So I'm going to take a guess that if I were to plug this in, that it would be stuck at 5 volts rather than 20 volts because it is not able to negotiate 20 volts from the charger because the USB-C chip is not working because its ROM is corroded. So let's see if our guess is correct. Now, the first thing I got to do before I even try plugging a charger in, as you can see, ow, ouch. Okay, that is nasty over there. That is quite nasty. So that has seen better days. There's also a chance that this is corroded so badly that the charge port may be... I hate when that happens. This may be shorted to ground internally, but there's only one way to find out, right? So I'm going to clean it off a little bit with some alcohol and a Q-tip, and get started. And to be clear, these are not ideal pins, but let's just see. Most likely going to wind up asking Paul to replace the charge port on this. So when I plug the charger in, it's not really much of a surprise to see that it doesn't even respond. It's like I'm not even going to dignify this with a response. With the other charge port, you see it gets to 5 volts, right? But it's stuck at 20 milliamps, and it never goes to 20. It's stuck at 5. So usually what happens is one of these chips, because there's one for each port, is going to speak to the charger and say, I'm not a GoPro, I'm not a phone, I am a laptop. I need 20 volts. But this chip is not turning on to do that because this chip has a ROM. It reads from that ROM. It gets information from it. It figures out how to live life, how to do whatever it does. And it does that from this. And this looks like shit. So, first thing what I'm going to do, let's try and make this look a little less like shit. So let's just kind of observe, clean up a little bit. There's some mild cleanup here. It would cost all of your money, Royal. Whatever you have in your bank account, we just take it. We take all of it. Okay. Now, as you can see, there are 2 pads on the left here that look pretty bad. So I'm going to assume that this resistor is not even soldered to anything anymore. This one and this one. And let's take a look on the schematic and board view to see what that's for. What do you know? So that's 3.3 volts, looks like. That looks like probably a 3.3 volt pull-up. Yeah, it looks like a pull-up resistor. Now, a pull-up resistor is going to be used to create a data line. We go over that in the basic guide to board repair. So over here, you can see this is 3.3 volts up here, and on the other side, you have the SPI data line. So for those of you who are curious what I mean by that, let me just bring up my beginner's guide. Okay, so are you ready to see probably one of the worst descriptions of how a circuit works in your life? Are you ready for this garbage that I call education? Okay, let's do this, bro. So check it out. What is a pull-up resistor? A pull-up resistor keeps the signal high. When it is not being shorted to ground, it will be 3.42 volt. A pull-up resistor isolates a data line from the main power supply. You can have as many data lines as the power line is capable of providing amperage for on a given data line. And what happens when we create a data line without a resistor to limit current? Remember, the chips are shorting the signal to ground down to 0 volts to make this work. And I took a picture of, Sonny trying to build an e-bike with me. Over here it says this is why we use pull-up resistors. So I will show you an example of a data line. So here, creating a data line. The chip is creating data by shorting a voltage to ground, making a waveform that represents data. Without voltage present, it will always be 0, which will data. We need voltage to be present, so the chip has something to create a waveform from. So over here, you see, this is a data line, and as you can see, I did not care to respect the aspect ratio of this screenshot of the schematic when I was copying it into Microsoft Paint. You could tell I put a top-notch effort into this. This is the 3.4 volts. This is a resistor between the data line and the 3.4 volts, and this is the data line. See, the SMC can talk to this chip, can talk to that chip. So here's the 3.42 volt side of the pull-up resistor. See, it's just 3.42 volts of plain DC. On the other side, this is the data line. So it's kind of like, I don't know, just kind of think of it like one of those little, what's the word I'm thinking of? You ever see one of those little Morse code things where he's like, like a telegraph, It's like really overly simplistic explanation, but you get the idea. The pull-up resistor is needed. Now, if the pull-up resistor is corroded over here on the 3 volt side, think about it. If it's corroded on the 3.3 volt side, that means that we probably don't have jack shit going on over here. So if this side is corroded, which by the way, that's the side that makes sense to be corroded because that's the side with all the power. That's the side with, the actual 3.3 volts. This is it after 3.3 kiloohms of resistance. So it's natural that all the corrosion is happening on the left side of the resistor, pin 1, over here, rather than the right side of the resistor, which is just data, pin 2. So that means we most likely don't have the ability to create a line here. And we also have this little probe point over here, which looks massively screwed up. And you take a look over here. That is, oh, that's no good. That's no good. That's no good. So that is the path that this is going to be taking to here. That's bad. That's bad. Well, let's have some fun. All right? Let's try and touch this all up. You have a little ROM chip. Vroom. We're just going to put a tiny, tiny bit of flux over there. Just a small amount of flux. All right? Not too much. Not too little. Most certainly not a Paul amount of flux. We don't believe in that over here. And the first thing we're going to do is we're going to remove the affected chip. Now, the chip itself may be good. Chip itself may be good. Get that guide off of the screen. That is the most juvenile kindergarten thing I've ever written in my life, that guide. I made that guide with the idea that other people trying to learn this would be as stupid as I am. So you try to keep it as simple as possible, so that even an idiot like me can get it. Alright. Now, it's a very, very small ground pad over there. We're just going to do the pins. Again, you don't want to solder on top of corrosion. What I'm trying to do is I want to get any of the corroded, nasty shit to get sucked up into this giant, fluxy solder blob over here. And then that solder blob falls onto my desk, and all the corrosion and nasty crap is gone with it. Gone with the wind. Also, all that red stuff, that's the board bleeding. The board bleeds and gets really sad when it gets water damage. So that's motherboard blood right there. When you see all that kind of, that red rust-looking powder. Again, you cannot solder on top of corrosion. That's not how any of this works. I'm using the iron to gently scrape. And admittedly, I shouldn't be using this iron because these tips are like $50 now. This is a T30-KN. And if Paul were here, he'd be walking into the office and probably smacking me over the head with something, because he's the one that always has to order these after I break them. I think Paul may still actually have his original tip from when he started here in 2017. He's a madman when it comes to stuff like that. I don't know how the hell he does it. I can't. I can't figure out how he manages to do stuff like that. He's very talented when it comes to stuff like that, like little things, like just not, I guess, how about this? Not doing harm to whether it's a tool or a pad that's left or anything else. He has the exact opposite mentality that I do of just, you know, run in, Leroy Jenkins it. His method is probably better. Who am I kidding? It actually is better. Now remember, we've also got that other part down here, that little probe point that's dead, and I might up the HDR just a little bit, give you a little bit more HDR so you can see it. HDR does make the image washed out, but it allows you to see certain details that otherwise would have been invisible, like this over here. So I'm going to be able to see what is going on over there. I want to see if there's any remote chance of that coming back. Now my question is now going to be, is that go into the board? Or is that like, what is that specifically for? So on the schematic in the board view, it looks like this Thunderbolt ROM chip speaks to this Thunderbolt chip over here. This Thunderbolt chip is going to speak to the Thunderbolt ROM through this resistor. But my concern is, does it go through here? Is this for my benefit? Like, is this just for me to be able to do the measuring? Or does this actually come around here, go through here, and then go there? Because if this goes around here, through this, and then goes there, obviously I'm screwed because this no longer exists. However, if this goes to here or here directly, and then out here just for my benefit to be able to measure, then I don't have to care about that missing so much. Do you understand where I'm coming from? Hopefully you understand where I'm coming from. I'm going to do a little bit of scraping around there just so I can try and potentially learn, maybe see what's actually going on. If I was really, really genuinely curious about this, one of the things I could do is actually remove that chip I could remove this chip on a donor board, and then I could measure this to this if I cut out that. But that's a little bit too much work. By the time I do that, I could have literally fixed this board. So what I'm thinking of doing over here is scraping and running a little jumper wire right across this little probe point. I'm not very steady with my hands anymore, unfortunately, which is why I do less of these videos. Luckily, I have a talented staff now that's able to take care of all that. So I can't really... What I want to do is I want to scrape just the trace. Just the trace. But I lack the accuracy to be able to do that. So this is not going to be, admittedly, as neat as I'd like it to be. However, it will be more than neat enough for the job to be done and for this to be able to last for a very long time and never come back for warranty. Oh, it looks like there's a Paul in the chat. Is it Paul S or Paul D? Which Paul? Okay, so I'm going to need something else to scrape with. Now, just in case Paul S is in the chat, I need to set a good example, and I will not scrape with tweezers regardless of how dull my knife is. I have another knife that's a little less dull. And again, the hand thing is really kind of screwing with me here, but... Oh well, what are you going to do? Can't cry about it. That's not going to make anything any better now, is it? You make... Watch, see? The way I see it is, it's actually helping me. See, instead of me having to do the work of move it back and forth and do the scraping, it's like automatic. Look at that. It's kind of like you... Get there, you piece of shit. There we go. Okay, so this is going to be a strange one because we've got a bunch of different pieces over here. So we have this plane. That's a separate plane. So you see how many different planes we have over here? Look, this is important. So this, I imagine, is going to here. This looks like a separate plane for something else. And we can't mix them together, and we can't confuse which one's which. So what I may do, just for fun, just to be able to get a better idea, I think it may actually make sense if I scrape away at that point on a donor. Let's take a look at a donor. I could scrape this away on the donor board. By the way, this really gives you an idea of how much damage water does. Look at how hard it is to actually scrape this probe point off with a knife. Like, that shit... Like, I'm putting effort in for that. That doesn't come off very easily. Okay, so this probe point goes there. What is this thing under it? So there's something under it. I want to see what the thing under it attaches to. Do you understand why I'm doing this? Because I want to make sure that I'm not attaching the wrong thing to the wrong thing. So this is going to say 0 when I attach together. You understand that? So over here, this is not supposed to attach to this side over here. Okay, good. However, this layer under it, yeah, that layer is not supposed... So this thing that's under it, this little ring that goes around the area I need to solder to, that also doesn't attach to that. So just don't touch that. We're going to avoid touching that altogether. Okay. So we need to do... I am going to run a jumper. I just dropped my tweezers. That could have been painful if I dropped them in the opposite direction. We're going to attach a jumper from here to here, and that's going to be that. Now, one thing that's pretty important to here, first thing, is make sure that I don't wind up just creating a solder blob all over everything. So a little bit of precision is going to be necessary here, which is what makes this such a shitpost that I'm even trying to do this, but whatever. YOLO. And we're going to do this. And a little bit of solder here. And I don't want to solder the periphery. So I want to get that little nub in the middle without soldering the periphery that's going to something else. Do you understand? Does it make sense why that's my goal? I don't want to combine layers together. So. Okay. Now let's get a wire. We got a wire. Nice little jumper. I should have some links in the description down below if anybody's curious where to get wire. Those are also affiliate links, so if you buy wire through me, I get like 1 or 2%. Ain't that grand? Helps me pay for all this flux that I overuse in all these videos. Okay, so we're gonna tin the wire now. That went like shit. Okay, let's try that again. I'm smart, I'll edit that out, but I'm not, so I probably won't. Let's try that again. Let's try. Oh, yeah, this is. I think these tweezers are making me look worse than I actually am. And I'm pretty bad, but I don't think that I'm this bad. I gotta find another set of tweezers. Oh, here we go. Okay. The silver tweezers. These black tweezers on my desk suck. Yeah, this says Ineasy. Yeah, fuck those tweezers. Let's get some proper tweezers. Something that can actually grab. Something that grabs. I need tweezers that grab like Andrew Cuomo. Here we go. That actually almost just about grabbed the wire. You want grabby tweezers. You want the tweezers to be like Cuomo. You want them to grab and then lock it down. Grab, lock them down. Grab, lock it down. There we go. So I've and now we're going to run the wire over here to the probe point, but without touching the ground section. Now there's a little bit of solder left on the end of my iron, and there's some flux that's still kind of left over here because this Amtech NC559 takes a long time to burn away, so I can use it like this. And then now what we want to do, a lot of people try to cut the wire or cut it to perfect length beforehand. LOL, that's never going to happen. Get out of here with your perfectionism. What you're going to do to make this feasible for yourself is you're going to move it back and forth. You just rock it like this, like that, like this, like that. And then even a spaz like me just cut a jumper wire to perfect length. See that? It looks like I cut the wire to perfect length. I didn't cut the wire to perfect length. If I tried to do that, I'd be here all fucking day, and I wouldn't do a single repair. The way you make that work is you just do kind of like what figured out when you were a kid. Oh, look, a paper clip will actually break if I bend it back and forth enough times. So you want to bend it back and forth, but after the solder joint. You don't want to use enough pressure that you actually mess up the solder joint. And if you're thinking to yourself, well, I don't want to use any pressure because it'll mess up my solder joint. If your solder joint is so bad that would remove it, then you have a bad solder joint, and it's better that you figure it out now than you figure it out when it's in the hands of the customer who needs it for perhaps mission-critical work. Well, if they had mission-critical work and they're doing it on a MacBook, then, well, that's a discussion for another video altogether. But now what we're going to do is we're going to replace those two resistors, those two pull-up resistors for our data line. And we're also going to replace that ROM chip. Now, luckily, this is not like Intel Management Engine firmware, where that particular ROM chip is specific to that individual board. We can replace that ROM chip without having to reprogram it. Something a lot of people don't understand when they're replacing BIOS chips on any machine that's been made after a Core 2 Duo is if you do need to reprogram something called or copy over Intel Management Engine region. There are people that will just change a BIOS chip and something will work again, and they won't realize that, oh, the reason it's working slow or Wi-Fi is not working properly or graphics is weird is because the management engine is different. So the PCH, Platform Controller Hub, I believe, that's what used to be like the North Bridge and the South Bridge and all that type of stuff on older computers. That is specifically paired to the BIOS. Or, you know, if you're on a MacBook, you don't call it BIOS, you call it SPI-ROM. But who the hell wants to say 4 syllables when they could say 2? I like BIOS. I'm not calling it an SPI-ROM just because it's on an Apple. I love BIOS. So I'm going to grab a ROM from a neighboring one, and we're going to make this beautiful. Are you ready? This is going to be beautiful. And it's going to work, too. You'll see. This is going to work This is going to be sexy. It's going to get 20 volts. Okay, we got a ROM chip. Now watch this. Here's another thing that helps. So you may say, Louis, that chip's all crooked. That looks horrible. And you're right. It is crooked. It does look horrible. Watch this. See that? It's called surface tension, baby. Look at that. The chip literally goes where it wants to go. And it doesn't matter how much of a spaz I am, still winds up looking like factory in the end. And that's what we're looking for. You want little life hacks that allow you to be a spaz and still be able to do work that looks like factory. There's all little ways to get around the things that don't make you perfect at something, if you're open to it and you're interested in trying. But that's a big part of it. You have to be interested in trying. You have to be willing to say, I may not be as lucky as somebody else. I may not have what they have. I may not have natural skill. I may have not blah, 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 blah. And I may not be as good as them. But am I open to trying a way to get around my things that don't make me as good at something so that I can actually get something done? Now we're going to take our two resistors, the little pull-up resistors, and we're going to use our tweezers and our hot air to copy them over. I just said the word copy instead of move because I'm losing my mind. You do not copy and paste resistors. That would actually be a lot easier if you could copy. Imagine if you could copy and paste actual chips. Like, I would only need to find one CD3217 ever, and that would be the end of it. Again, same principle here. I don't care that that resistor is all the way off the pad. It doesn't matter. There's enough flux on there that it's going to move right into place, and it's going to look beautiful. You'll see. So you know what? Let's put a little bit more, just in case Paul S. is watching. We're going to trigger him. You ready? Look at that. Okay, watch this. 3, 2, 1. Oh, yeah, look at that. Settle into place. Same thing's going to happen to the wire. The wire is going to settle into exactly where it wants to sit. That wire looks like it's sitting a little bit above actually where I would want... Yeah, oh. Note to self. Don't be a perfectionist. Okay. I don't think there was enough solder on that section, so we're going to just go over that again. I don't like the fact that I can see as much of the outline of the wire as I can. That's bothering me. But I don't think I put enough solder on there because I think I was afraid that I was going to touch the surrounding area and then wind up shorting everything together, which is a legitimate concern. So I'm going to try holding that wire down with my tweezer while I am tapping it with the iron, which is probably a risky thing to do, but I want it to be nice. Come on, get back over here. That you shouldn't be a perfectionist, but you shouldn't let stuff go out that looks bad either. Okay, now we're going to inspect what's on the other side, all right? Because I see a probe point that could look considerably better. You see this? What is this? I don't like this. Okay, it looks a little bit better after I move over it, but we're still going to keep that in mind. That appears to be an SPI clock. SPI clock, and that's going, let's just see, from here to there, but then also to the other side of the board. This is a tough one because I want to make sure that that actually is working. But the problem is I have to measure on two sides of the board at the same time, which is really an absolute pain in the ass. We can try it, though. Just want to make sure that that's going through. Now, if I had half a brain, I would just try to see if this turned on rather than do this. So that pin, third resistor down on the left. Oh, Jesus Christ. And a third resistor down on the right, on the left side of the chip. This sucks. This sucks. Good enough for me. Okay. I'm probably not putting the requisite amount of pressure. All right. Here we go. We have any changes? Okay, as you can see, we're up to 20 volts and 500 milliamps. So the CD3215 is now capable of turning on. It's turning on because of the ROM now working, and it is negotiating with the charger to get its full amount of voltage so that it works properly. And that's that. That's pretty much what we were looking for. We're looking to make this machine work again. Now, so one of the things that we may do later on, just to make sure that this does not come back later, is replace the charging port. And on this model, admittedly, it is a bit of a pain in the ass. It's a little bit more of a pain in the ass than other machines that use more standardized kind of USB-C, more easily solderable charging ports. This uses an annoying through-hole solution where the holes are a little bit higher than the pins, so it's really hard to get inside of there and make sure you did a perfect job. But that's what I would do just to make sure that everything works. Hopefully this concept of some basic soldering tips, running jumper wires, finding corrosion, what does a data line do? What is the importance of a data line? When you see a chip that is corroded, try to having like the way that I try to figure out what that chip does, all that type of stuff. Hopefully this helps you when it comes time for you to fix a motherboard. And also, one thing I will continue to shill over here is Repair.Wiki. If you ever want help when it comes to fixing MacBook motherboards, let's see if I can get that to show up over here. Here we go. We just click on laptops, Apple, MacBooks, MacBook Pro, and there is a lot of really good stuff here. We have a bunch for this machine, and also upcoming are actually a bunch of air guides from Tim Herman at TCRS Circuit. He deserves a lot of credit for writing these guides. Look, this is for some of the new MacBook Airs. I mean, this is like 10 pages worth of stuff. This is like a good 10 pages worth of stuff that Tim Herman was real happy to donate here, and I am really intensely grateful that he did. And this is his YouTube channel. If you'd like to check out his YouTube channel, it's TCRS Circuit. He does a lot of how-to videos on doing MacBook board repair, and I'm really happy to see that his business is doing well. But more importantly than that, I'm really happy to see that he is still keeping up with and learning how to do these repairs on the newer models. And I'm happy to see that, again, he's just using his brain to figure out what's going on with all the new machines and, have a list in his head of all the things that go wrong with them. And this is really quality stuff, and if any of you want to contribute to Repair.Wiki, I'm humbled and honored to have you contribute. The idea here is to take repairs that otherwise would be difficult or not economically viable and feasible and make them economically viable and feasible for normal, average, ordinary people that are just starting to get into board repair. That is what we're trying to do here with guides like this. Again, the whole concept behind this guide is let's make it as easy as humanly possible to understand how all this crap works. When your average person sees this, their brain just melts, so I try to make it simple. We try to say that you start with 8 volts, it turns it on and off, it averages it out into this, and this is what it looks like every step of the way. So see, 8 volts, a little bit of 8, a lot of 0, a little bit of 8, a lot of 0. This is 0. On the other side of the inductor, gets averaged out into a nice little 1.7. The whole concept here is to try to take something that otherwise would be incredibly difficult and make it easy for people to understand. And that's about it for today. As always, I hope you learned something, and thank you for your contributions. Thank you for your viewership over the years. Thank you for choosing to fix a board with me. See you all in the next video. Bye now.